Okay, so good day everyone. So today we're going to have an example of a truth table having three inputs and also having three outputs. Okay, so the inputs now that we have are A, B, and C, and then we have also outputs F1, F2, and F3. Okay, so based on the design of the truth table, so if all are 0, meaning it is turned off, then all output should be on. Okay, and then you have if C is pressed, then F3 should turn on. If B is pressed, then F2 should turn on. And say for example, if you have B and C are pressed, then F1 should turn on, and then so on and so forth. Okay, so that is the sequence of the output based on the inputs. Okay, so the first thing that we're going to do here is we're going to solve for the equation of the given truth table by using K-map. Okay, so we're going to use K-map for this one. Now take note, we have three different outputs. So obviously we're going to solve each output. Okay, and then meaning you're not going to solve all of them in one setting, but you're going to solve each output individually, okay, using K-map. And then later on, once you're done already with your solution and you're able to uh, come up with the equation, then what you're going to do is you're going to integrate all those outputs into one circuit. Okay, so I'm going to show that one later on. But first, we're going to solve first for our for the equation of each outputs. So, okay, using K-map. Okay, using K-map. Okay, first we're going to find the equation of your F1 output 1. Okay, so we have here a K-map table. Okay, A and C. Okay, so you have 0 0, and then you have 0 1 1 1 1 0. Okay, and then for your C you have 0 and 1. Okay, so again, this will depend on how you're going to make or you're going to set up your table in your K-map. Okay, so it might be that my equation is different from your equation because you have also a different setup of your K-map table. So it depends on the setup. Okay, so here in the first output, when all are 0, A, B, Z, and 0, therefore your output F1 is equals to 1. And if 0 0 1, then output F1 is 0. You have 0 1 0, that could be 0. And you have 0 1 1, that is 1. Then you have also 1 0 0. 1 0 0 at the bottom, that is equivalent to 1. And then you have 1 0 1. So 1 0 1, that is equivalent to 0. Then you have 1 1 0. So 1 1 0 is equivalent to 0. And you have 1 1 1, that is equivalent to 1. Okay, so that is now your K-map table. So next thing to do is we're going to group this one. Okay, we're going to group all our ones. This could be your first group, and also this could be your what, second group. Okay, so after grouping, okay, so the next thing we're going to do is we're going now to solve. Okay, so the first group will be, okay, this one is the first group, so that will be A bar. Okay, then B, and then you have C, plus you have A, B, and then you have C. Okay, that's the first group. Okay, the second group will be, okay, this is the first group. Okay, the second group will be this one on top. You have A, B, C bar. Okay, and then you have plus, you have A, B bar, and then you have C bar. And then we simplify. So what is the common here? So the common here is B and C. So common B and C multiplied by A bar, and then you have plus A. Okay. According to the Boolean rule, A bar plus A, that will be equivalent to 1. Okay, then you have the other side, the next group, this one. The common here is we have B bar and C bar. So we have B bar and C bar times A bar plus A. So A bar plus A, that is equivalent to 1. So what remains here is we have BC plus BC bar. Or this is equivalent to, we can simplify that one as you have B, okay, XNOR of C. Okay, XNOR. So this is now your first equation. This is now your F1. Okay, this one. Okay, that is now your F1. Okay, so next we're going to proceed to F2. Okay, so I will just erase this one. Then we're going to solve for F2. Now take note of the first equation. So the first equation is B XNOR C. Okay, that's the first equation. So let's proceed to the second equation. Okay, so you're going to solve for F2. Okay, so by the way, we're just going to write on top. Okay, so that you will not forget the equation. So here we have, say, F1 is equals to B XNOR of C. That's the equation of F1. So that we will not forget the equation. So next, we're going to find the equation of F2. So again, you have a K-map table here, A and C. Okay, so you have 0, 0, 0, 1, 1, 1, 1, 0. Okay, on the other side, you have 0 and 1. Okay, so next, we're going to find out the values inside your cells. So in F2, okay, if all are zeros, then that is equivalent to 1. And then if 0, 0, 1, that is equivalent to 0. If what is 0, 1, 0, equivalent to 1. Then you have 0, 1, 1. So 0, 1, 1 is 0. And next is 1, 0, 0. That is 0. Next you have 1, 0, 1. That is 1. Next we have 1, 1, 0. 1, 1, 0 is 0. And 1, 1, 1 is equivalent to 1. Okay? So this is now our values. Okay. Next, we're going to group this one. We're going to use the red color so that it is clear. Okay, the grouping. So this is the first group. And this is not the second group. Okay. So we're going to find now the equation. So the first group, you have A, B, C bar. Okay. And then the second cell is you have A bar, B, C bar. Okay, this is the first group. Okay, the second group will be, okay, you have 1, 1, 1, so you have A, B, C, plus the other one is you have A, B bar, and then you have C. Okay, this is the second group. Now let's simplify. What's the common in the first group? So the common in the first group, you have A, C bar times B bar plus you have B. So this will be equivalent to 1. And in the other group, the common is A and C multiplied by B plus you have B bar. Okay, and it's equivalent to 1. So simplifying, we have AC bar plus AC. Or this is equivalent to A X NOR of C. Okay, this is now your F2, the equation of your F2. Again, so that you will not forget, we're going to write the equation of your F2 on top. So F2 here is equivalent to A X nor C. Okay, that's the equation of your F2. Okay, so next we're going to find the equation of your F3. So we're just going to erase this one. Okay, so F3, equation of your F3. So again, we're going to have a came-up table here. Okay, C. And then you have 0, 0, 0, 1, 1, 1, 1, 0. Then 0, and then you have 1. Okay. So, okay, if that is all 0, then it should be 1 here. If 0, 0, 1, then it should be 1. Then the other one is, you have 0, 1, 0, that is 0. 0, 1, 1, that is 0. And then you have 1, 0, 0, that is 0. 1, 0, 1, that is also 0. And then you have 1, 1, 0. Okay, that is 1. And 1, 1, 1, that is 1. Okay, so this is now your came up table. And then we're going to group. First group. Okay, this will be the second group. Then we're going to find now the equation. So, solving for the equation, we have the first group. Of course, you have A, B, C bar. Okay, plus you have A, B, C. Okay, A, B bar, C. Okay, the next group you have A, B, C bar, plus you have A, B, C. Okay, first group, and then you have second group. Okay, so simplify. That's the common. So the common here you have A, B bar times C bar plus C. So this will become 1, plus the common here is you have A, B, okay, times C bar plus C. Again, is equivalent to 1. So we have here A, B bar plus A, B. Or this is equivalent to A, X nor of B. Okay, this is now your F3, or equation of your F3. So again, equation of your F3, F3 is equals to, you have A, X nor of B. Okay, so these are now the three equations of your of the given truth table. Okay, so after this, what we're going to do, we're going to convert this into circuit. Now take note that we have three equations or three outputs. So therefore, what we're going to do is, even though we have three different outputs or three different equations, but in our circuit, okay, so what we're going to do is we only have, or we're going to integrate the three outputs into one circuit. Okay. Okay, so here we're going to convert that into circuit. Okay, we're going to use the blue color. So take note, you have inputs A, okay, B, and you have C. These are now your inputs. Your F1 is B XOR C. Okay, XOR C. So the symbol for XOR is this one. Okay, you have this one, and you have, okay, XOR. Okay, that is the symbol of your XOR. So B XOR C, so this will be our F1. So we're going to have here, say for example this one, this will be your F1. We're just going to arrange your F1 to your F3. Okay, this is your F1. Then you have your F2. Okay, F2. And then you have now your F what? F3. Okay, F3. So here the first input will be B XOR C. So this is now your inputs. Okay, this is B XOR C. Okay, that is B XOR C. Your F2 is A XOR C. So A, okay, A, X nor C. So we're just going to tap here. That is A X nor C. That is your F2. And then your F3 is A X nor B. So from here, we're just going to tap. That is A. Okay. X nor B. So here, we're going to tap B. Okay. That is now your A X nor B. So that is now your equivalent circuit. So take notes. We have three outputs. Therefore, we're having three equations. But what we're going to do, we're going to integrate all those three equations into one circuit. Okay, so this is the equivalent truth table. Then we have now the three different equations, F1, F2, and F3. Then we are now converting that into its equivalent circuit. Now, what we're going to do, we're going to check if our truth table is correct. Or, I mean, if the circuit is correct based on the given truth table. So, how are you going to do that? So, actually, we can do it here by putting zeros and ones in your inputs. But, for you to be aware of how we are going to use ProChoose, so we are going to check the output of our circuit through ProChoose. Okay, so I will be introducing you the ProChoose software. Okay, so that's all for today. Thank you for listening and have a nice day. God bless everyone.